So, welcome to lecture number 9. And in this lecture, we are going to try to solve a paradox that was raised in the previous lecture, maybe third or fourth. I do not remember the lecture number. And the paradox was this: a line, the thinking style. See, we thought a line is made up of points, maybe infinite points, and of course, infinite points. And we also know from the definition from the Euclid books 1 about point that a point has no parts, and that means a point is sizeless, it has no size whatsoever. So now we have the two scenario. Here is a point and this point has no size, and then here is a line and we think that this line is made up of infinite number of points which has no size. Then the question was, how come after collecting infinite number of sizeless object on this line creates the effect of length, size? We can think this way. A line has a length, right? Everyone knows this. Take a scale and measure, we can measure this. And we get maybe 5 centimeter, 10 centimeter. It has length. And the line has length. And if we think a line is made up of infinite number of points, and all those points have no size because point has no length, no breadth, no height, then how come summing the size of all those points we get length, a line, a one-dimensional object? Point is a zero-dimensional object. Collecting all the zero-dimensional object together, you cannot form one-dimensional object. You see what I'm trying to say? We have points. A point has zero size, and here is a first point. Now you put another point on top of it, then another point you put top of it, and you do this stacking, the stacking of infinite number of points, and we think we're somehow creating a length. Well, that is not possible because the very first point has no length, no breadth, no height. So if you put one point on top of another, it is not going to create length, you see, no matter how many points you put. So this is a paradox. If point is made up of infinite point, if a line is made up of infinite number of points, then it is not possible to have length. And this paradox can be applied to this idea of plane. If we think here is a plane, let's say here is a plane, this is a plane. Now okay, so here is the plane, and this plane, this surface is a two-dimensional Euclidean space. It's a two-dimensional plane, and we think maybe this plane is made up of lines, infinite lines, right? Now if this is made up of infinite lines and line has only length, then how come stacking one line on top of another which has only length creates this breadth? That is impossible, you see, because the line has no breadth. If you put one line on top of another line and then another line, you are not extending this. You cannot create area out of it because a line has no area. It has only length. So no matter how many so no matter how many lines you're gonna put on top of one another, you are never going to create area, never going to create a plane. And same thing happen with a cube, a three-dimensional object. Let's say we have a cuboid. We can think of this notebook as a cuboid, right? It has it has some length here. We can imagine this as length, this is breadth, and this is height. So here is a length, and then here is this breadth going on, and this is the height. Now we think this cuboid is made up of infinite number of planes. Here is first plane, here is second plane, third plane, and so many planes are stacked together. So many planes here you can see, right? And these all planes put on top of one another, and it is creating a three-dimensional object. Now is that possible? Because a plane has only area. If you put area on top of one another, a flat surface, you put on top of one another, you cannot create height. There is only area. How can height come out of it? A plane has no height. So a heightless object put together on top of one another like a stacks, you cannot create height. So it is a paradox. So how can we solve this paradox? You see, there is no paradox at all. The paradox comes from a very a very discrete kind of thinking. You see, discrete kind of thinking. We think a line is a discrete object. If you think a line is a discrete object, then well, yes, adding one thing on top of one another, it creates something. Line is not a discrete object. Line is a continuous object. It is complete in a sense. There is no gap between one point and another point. You see, I don't know how to put this. I think we should try to do this on the paper, so we get let's say maybe okay. So here is a point, and the size, let's say S for size. So it's a function. It takes an object and produce size. So we know size of a point is 0, right? And size of line is some length L, right? Size of plane is some size P. We call it area. And size of let's say cube is C. We call it volume, right? Now if we think a line is made of infinite points. These are the points, and there are infinite points put on top of one another, and you get creating a line, then that is wrong thinking. Because so if we say here is a point, and you put one point on top of one another like this, and we think we are creating this line, but that is not the right way to think. Because a point is zero-dimensional object, it has no size. So if you put one point on top of one another, it cannot extend. There is no extension happening here. You see? Because zero size. How it can produce length? That is not possible. So what is size of line? If we think size of line is sum all the sizes of point. This is summation symbol. Sum all the sizes of point. Which point? All those points that belongs to this line. Then what happens? Well, we have infinite points, so we have to add size of point 1, size of point 2, size of point 3, and so on up to infinity. Well, we know from axioms, the definitions, which is point has no parts. It has length 0, it has breadth 0, it has height 0. So what is the size of point? Size of point is also 0. So it is 0. Size of this point is also 0. Size of this point is also 0, and so on. Well, P1 and P2 is same. Same in a sense, they have the same property. P1 is similar, because how do you say 2 points are same? Because they are the same object. It can have different label. We can label this with P1, we can label this with P2. Well, that is different point, but not different in a sense they are a different object, they are still points. It has a still zero size, it has a still zero size. So that is why you can substitute 0 for all of them. So it is also 0, and that is, and it will go on and on up to infinity. Now you add 0 infinite times, you get 0. It means size of line is 0, but that is not possible because line has a size, it has some length. We know this size of a line is L. So how does it produce 0? So we cannot say that stacking point on top of one another we create line. This is the wrong way to think. That same goes with plane. Let's say size of plane. If we say sum all the size of line and all those line belongs to this plane, then well, how many line we have? A plane has infinite line. So size of plane 1, size of plane 2, and so on. What is the size of this should be line, size of line 1, size of line 2, and so on. So what is the size of line 1? L1. What is the size of line 2? Well, a plane has equal number of lines, all line on the plane has equal length, and they produce, if you put equal length of plane, you produce a plane, right? Or it could be different, right? They could have a different length, right? Different length. So suppose L1, L2, L3, and so on. Now these all are length. How many L? It only produce a length. If you sum all those length, you get a number, length. You do not get area, right? So we are adding length only, and this length cannot be area because plane has area. So how does it happen? And the same we can argue with cube, right? A cube is what? Size of a cube. If you think we sum all those sizes of plane and those all plane belongs to this cube, then what happens? Then size of plane 1 plus size of plane 2, and so on. Size of plane is, let's say, has area A1, size of plane 2 has area A2, because what is plane? Plane is length and breadth, its area is L into B. So every plane has a different size, so A3, but for the cube all plane has same size, so A1, and so on. So we get n times A1, which is still area, it is not volume. But size of cube is area. Well, the size of cube means it has a volume effect, it creates volume. So what is happening here? The paradox is in thinking that we think line is made up of point. Here is a point, and putting together all those points we get a line, and putting all those together line we get plane, and putting all the plane we get, let's say, a three-dimensional object, say cube. But this is a wrong way to think. Plane, line, point, line, plane, and cube, they are all different primitive objects. Euclid in his book 1, he never defines line as like this. It is made up of points. It is collection of points. No, that is a wrong way to think, because the moment you define line as made up of points, you run into a paradox. See, he defines line is a breadthless length. That's all. No need to say line is made up of points, or plane is made up of lines, and so on. No. Then what is the right way to think? The right way to think is point is a primitive object. It's a different object. Line is a different object. Plane is a different object. Cube is a different object. All are different. But a line, on the line we can assign location, a point, P1, P2, P3, and so on. Because we know we have the axioms, Betweenness axiom. It's called Betweenness axiom. This axiom says, given 2 points on a line AB, there is always a third point in between them. C. Given 2 points in between A and C, apply a Betweenness axiom, and there we get a next point, D. In between A and D, we can get again another point. So it goes on and on. It is a continuous, but it does not mean line is made up of point. It only means on the line point lives. Point belongs to line. We can define point using line, not the other way around. I mean, other way around you can do it, but it does not mean point line is made up of points. You see, we have to think in reverse order. A point is defined using a line. What is point? Point is an element of line. Similarly, you can define line using plane. What is line? Line is a subset of plane. You see? And this goes on and on. So lower dimensional object lives inside. It is a subset of higher dimensional object. Zero dimensional object belongs to the one dimensional object, and one dimensional object belongs to 2D, and 2D belongs to 3D, and so on, right? They are isolated objects. You see, you cannot define 1D using 0D, zero dimensional. Well, we can, but it does not mean 1D is made up of 0D. That is a wrong way to think. Line is a continuous object. You see, a line is a continuous object. There is no break in this. There is no gap. It is complete. Line is defined using completeness, continuity, betweenness. You see, it is not defined using points. The moment you define it using points, we run into a problem. But we do it all the time. Even set theory says, what is line? So line is the collection of point x, y that belongs to line, such that this x, y satisfy the equation ax plus by plus c equal to 0. We do it in the coordinate geometry too. But it does not mean collection of all those points p1, p2, p3 and so on is what making the line. No. Here is the line. We can assign position p1, p2, p3, p4. We are free to do that. But we have to remember that this line is not made up of points. So there is no paradox. Paradox only comes from the thinking that line is made up of points or plane is made up of lines, so on. But that is not the right way to think. In the school, we are always taught this way, that there is a point and the line is made up of points. But that is the problem, because zero size object cannot produce 1D. 1D size object cannot produce 2D and so on. So they are different primitive objects. That is why even if you read Hilbert axioms of geometry, they are defined this way, using betweenness, congruence, incidence and so on. They never say line is made up of point or plane is made up of line. They are considered primitive objects in Hilbert axiom too. Point, line, plane, these are the all primitive objects. You see? So the moment you all define them using point, we run into a problem, and the problem is the paradox. Well, that kind of thinking is good in discreteness. You put one brick on top of one brick and you create a wall. But that does not happen in continuous structure. Continuous is not discrete, it is a continuous. You see? You cannot divide it. I mean, you can divide it into section intervals, but it doesn't mean they are made up of points. You see? So this is what we have to think. So this is how we solve this paradox. We have to separate those objects. We don't mix them together. You see? For now, I think this is enough, and in the next lecture we will start talking about other kind of stuff. The reason for doing these all kind of things was, we started with backtracking, and for this backtracking, to make you understand, to make this thing clear, we started using Euclidean geometry as an example, and we saw through backtracking process we saw what kind of axioms and presupposition Euclidean geometry assume, and we saw it not only assume the geometry of axioms but also logic, and when we broke the logic from classical to fuzzy logic, we got different kind of geometry, right? So this was the idea behind what is backtracking, what are the assumptions, hidden assumptions in a theory. And from now we are going to talk about structure, and that will be in the next lecture. For now, thank you.